All right. We are looking at our 7th grade math review for week 14, day 3. This is Wednesday, and day 4, Thursday. All right. Day 3, we're looking for what was the original price. It says GameStop is having a sale and all games are reduced by 55%. If a game is now $29.99, what was the original price? Okay, this problem is a little bit tricky. We could explore it with our bar model, but I'm going to try to use some of the algebra that we've learned recently. I'm looking for the original price, so I'm going to let my variable x equal that. X is equal to the original price. We don't know what it is, so we're going to call it the unknown x. Well, it says that our original price reduced by 55% will yield $29.99. I'm going to take $29.99 to be approximately 30. That'll ease our calculation substantially. Well, if we reduce by 55%, how much remains? Well, we know the total is 100%. If we subtract 55%, we will leave 45%. That is, this $30 represents 45% of our unknown original price. Well, we know that 45% equal to a decimal is 0.45 because percent means per 100. We simply move the decimal 2 places to the left. So now I'm going to make an equation. 45% or 0.45 of our original price, so we simply multiply, will equal $30. Here's what we're saying. We don't know what the original price is. We're calling it X. But 45% of that will be $30. Now we can simply solve for X. Since these are multiplied, we will undo by division, dividing by 0.45 on both sides. All right. 0.45 divides 0.45 to leave X. And over here we have 30 divided by 0.45. That's going to be a little bit of a tricky decimal division. I'm going to come over here to my scratch paper. 0.45 divide into 30. When we have the decimal in our divisor that's to the left, we will move it all the way to the right, and we'll make an equivalent movement over here. 2 spaces, and these empty spaces will get zeros. To say 0.45 into 30 is the same as 45 into 3,000. So 45 into 3 won't go. 45 into 30 won't go. 45 into 300. I believe that's going to go 6 times. 6 times 5 is 30. Carry my 3. 6 times 4 is 24. Plus 3 is 27. Now, 300 subtract 270 is 30. Bring down the 0. Again, we have 45 into 300 like we had previously. Well, that's going to yield 6 again. So 6 times our 45 is 270. We can introduce a 0 here and drop this down. But hopefully you can already see that we're going to have this repeating pattern. It's going to be 66.6 repeating. That is $66.66. We should round to 67. So the original price is $66.67. A was a pretty tricky problem indeed here. You could have kind of gotten an estimate. If it's reduced by 55%, that is more than half. And obviously, if we take $67, more than half of it, if we reduce by that, would leave us with a number approximately 30. Half of $66 would be $33, but we had more than half of a reduction, so it would be a number less than 30. All right, with that information, see if you can do B. Now we're going to drive on and look at number 1 here at the bottom. Let me do number 3. It's a little more difficult, and then hopefully with the knowledge on number 3, you can work number 1. So we have the -3 connected to the parentheses. We haven't seen too many problems like this, but this is a distribute. we know connected means multiplied, so this number is connected to both of these terms. We're going to multiply negative 3 times both terms in the parentheses. Negative 3 times p is a negative 3p. Negative 3 times plus 1 is a minus 3. We preserve the inequality, that is, leave it in the same direction, minus 18. We have negative 3p minus 3 is less than or equal to negative 18. Solving for p, we will add 3 to both sides. The negative 3 cancels the negative 3 to leave negative 3p on the left. Preserve the less than or equal to. Negative 18 plus 3 is a negative 15. Now solving for p, we will divide by the coefficient, negative 3. Negative 3 divides negative 3 to leave p. Negative 3 divides negative 3 to leave p. When we divide or multiply by negative, we change the direction of our inequality. Negative 15 divided negative 3 is a positive 5. So we want values of p such that p is greater than or equal to 5. We will come to our number line. We want to show p is greater than or equal to 5. When we come to 5, we put a point and we color in that point because since it has an equal to part, because of the equal to, we need a closed point. That is a colored in point. Number 1, you will have the same situation. Contrast that to number 4 over here on day 4. There is no equal to. Since there is no equal to, this will be open point. You do not color it in. When we have the equal to, we get a closed point. When we lack the equal to, we get an open point. All right. So we want values of p greater than 5. Well, values greater than are to the right on the number line, so we will shade then to the right. Notice when the variable is on the left, the inequality will point in the direction we're shading. The inequality is pointing to the right. We're shading here to the right. These are values of p greater than 5. All right, day 4. Let's work this first problem. We have 16f minus 8 equals 64. Solving for f, we will first add 8 to both sides. Negative 8 and positive 8 add to 0, leaving only 16f on the left. 64 plus 8 is 72 on the right. We have 16 times f equals 72. We want to solve for f. We divide by 16. 16 divides 16 to leave f. 72 divides 16. We can it's not a whole number of times, but we can convert this into a mixed number. 16 will go into 72 4 whole times with 8 left over. That's 4 and 8 over 16. And 8 over 16 reduces to 1/2. So this is 4 and 1/2. All right. We've seen 2 and 4 here are very similar to our 1 and 3 over here on the left. We should be okay with that one. Note on number 2, we have a division, so we will undo that with multiply. The one in the middle is a complete the table. Let's look at a couple of these. It says we have 55%. We know percent means per 100, so 55% can be converted to a fraction very easily by making it 55 per 100. A divide we read as per. Well, we can reduce this. What number goes into both 55 and 100? Well, it's 5. 5 goes into 55 11 times. 5 into 100 20 times. 55% is 55 over 100. It's also 11 over 20. This is the most reduced fraction here. All right. Decimal. Well, very easily. 55%, we simply move the decimal 2 times to the right. It's 0.55. if the denominator is 100, the numerator will tell you what the decimal is equal to that many places. Okay, 0.35. Well, to convert from a decimal to a percent, we simply move 2 places to the left. 0.35 is equal to 35%. Again, 35%, very similar to this problem here. I think with that, we should be okay on completing this table.